Right. So how do we factorize this? Well, as we said, right, just look at it as a difference of squares. And this kind of ideas we have seen in the past. Right? And then you input, right? And again, you can further factorize this, a square minus b square. Right? So that is not a problem. But then the issue with this is that this looks very different from the other factorizations. So in what way? I mean, this is like the best thing because we've completely factorized it. But okay, let's see. How would we factorize this? Try this one. So we know for a cube one I'm writing, so that if you want to take some hint or something from there. So just give this a try. Yes. So what should it be?
Actually, I think we did something similar in a class before for like the expansion a n minus bn, right?
Huh.
It is, so a minus b, and then it'll be like a n minus 1. I forgot after that. And then b comes, the first power of b will come.
Yes, right. So basically the power of A will decrease. And
Yeah,
the
the power
power
of b will increase. Yeah.
right. Okay. Pragdish, is it okay? I mean, we are not, it's not a proof, but it's the pattern based on which we are saying that this can be true.
No, I'm not really seeing the pattern here. Can you?
Yes. Yeah. So you see in this one, what's happening, right? You have the cube, but then it starts with a square. Right? Yeah, in fact, there is no, I mean, because we didn't discuss this in the same pattern, that's why maybe. Yeah, right. So this cube, but then it starts with the square, but then you see the power of A decreases. It goes from 2 to 1, and here it's basically 0. Right?
Yeah.
And the power of B is increasing. So I'm saying that is the pattern. Yeah. Like you see that same thing that's happening here.
Yeah, okay.
And this, but this, what I'm saying is that we had once said this in some polynomials class and so on. But today we are not going to go into this much. Okay? What I will ask is maybe try to come up with a reason of why this is true. Okay, and just give it a thought and see. If you don't want to do it for any, so you can try to use induction. You can use, there are actually several things, geometric progression, but just see whatever you can do. It's just, you have to just give it a try. It is this. Okay? So you can just try to explain this also for like 7 or 8. So that is fine. That much is okay. I wanted to do one more factorization, which is not in the same way. It's a generalization, not in the sense that the power increases, but instead of 2, what if there are 3 things? Okay, I wanted to go into that, but maybe we'll cut that short for today and we'll not go there. Instead, we'll go back to the problem. But please give this a thought, okay? Because in a way, this can be done by number theory, this can be done by polynomial, this can be done by pure multiplication, this can be done by not number theory, maybe it can be done by induction, those kind of things. Okay, but let's come back to the question. So the question that we had was, so Satya, what was, do you remember the question? This n plus 1 or 2n plus 1, something like that.
2n plus 1, I think, plus no times m plus n, I forgot. No, plus m plus n cube
yes,
equal to
that
100.
was, yes, right. So let us try this problem. Okay, so here m and n are integers. Let's see. Satya, your first step is to factorize this, right? Is that right? So yeah. So we simply, again, now what we have learned, right? What is there on the board here is this thing. So we ought to think of this as our A and this as our B, right? And just factorize it. So what does it become? 2n plus 1 plus m plus n, right? So that becomes 3n plus m plus 1. That's right. And then the other one is, this is a square so far we have not done anything but just applied the plot. What can we do next? What should we do next?
So just like before, we can group one term, right?
Which
for the previous problem.
Right, but in this one, which term will you group? Because see, the right hand side is not 0 and it is not, it doesn't have, for example, if you had 3n plus m plus 1, then it would have been very good, right? Then you can take this common, but those things are not there in this problem. So you have to think. So this is again a homework. Okay? I'll just give you a hint that that this is also a natural number, this is also a natural number. Okay, and the product of 2 is equal to 100. So you have to just look at the possibilities, right? For example, this could be 2, this could be 50, this could be, so things like that. Maybe I will make this number smaller. It's still not difficult at all, but I'll make this 16 or something, right? So this could be 2, this could be 8, this could be 4. You see those kind of things. Okay, then you will get two equations, right? For example, if you take this case, one, this is 2, that is 8. Then you will be writing right? This equal to 2 and this thing equal to 8. Then you have to try to solve this. 2 equations, 2 variables. Try to solve. Again, other case. 4, 8. You see how many cases you will have to consider. Right? So, okay. This is so do you see that there's a different flavor in this question, right, than the earlier question. So, but either ways, the other question is this question is number theory. You have to use that feature. Okay? It's not arbitrary factorization. So this is another homework. So today we have a few things to be checked and done. But I wanted to come to the, if this is clear, okay, otherwise you stop me and tell me. Okay. I wanted to come to another thing, which is along these lines. Right. Let us think about this. Again, solve. Okay, solve in reals. Okay, so it is. So it won't be a very good question because I'm just making it on the go, but the idea will come across hopefully. You don't understand. Yeah, let's try this. No, so I'm sorry, I'll just change the question 1 second. Okay, just apologies. Otherwise, this will solve in naturals. So x and y are natural numbers. Okay, and then you have to. So otherwise, it becomes the same question as the first question. No, anyways, let's try this. So x and y are natural numbers. Maybe I should put m and n. It doesn't matter. It really doesn't matter, but we are used to, you know. And Praktish, for you, there is one more homework. Using the factorization that we discussed, try to solve this. Where is the question? Just so you can note it down. So like the q plus b cube factorization that we saw today, try to use that and only one variable is there. Okay, and solve in reals. So this is like your A, and this part is like your B, and it's a cube plus b cube. So you have to factorize. When you factorize the left hand side, you will see some things in common with the right hand side. Let's try it. Maybe it's slightly incorrect. It should be x squared. So note is down. It does look a little challenging, but give it a try. And this AQ plus BQ factorization, you could try to look at some basic problems of that kind from any algebra book. Any algebra book you open, it will be there. Okay? Even your school book, maybe next grade, AQ plus BQ, and similar. Solve some basic questions in that for practice. Okay? So, any ideas on this question, Satya? Any ideas?
Yeah, just thinking.
So try using that same factorization, though once we learn a better factorization, it would happen faster maybe. But even with what we know so far, it can be done. And let's try that. So there are 3 cubes, but okay, you handle 2 cubes at a time. Take the first 2 and try to factorize it.
Yeah, when I expanded the first two terms, so I get 9m cubed plus 7m cubed minus 6m squared n plus 18mn squared. If you multiply, if you expand the first two terms.
No, why would you? No, don't expand, factorize, right? No, are you like expanding this a cube, a plus b whole cube?
Yeah, that's how I
No, no, but let's not do. Okay, you can do that, and maybe that can work. I'm not saying, but we want to factorize. Okay, you see, the factorization is a theme. I mean, you can do that also.
Or we can also take out m plus 2n and then m plus 2n squared. We can do that, right?
M plus 2n, m plus 2n.
Yeah, m plus 2n times m plus 2n squared, right?
That's right. That's right. But the point is that this is the sum of two cubes, right? This is a cube plus b cube, right? So we will do what we have been doing in this class so far, right? Let's factorize it, right? You see, when you factorize it, you get something interesting. You get 3m, right? You get a plus b, right? Plus n times something which is a little bigger. Yeah, it may not look very intuitive as to why, given three terms, there's no hope. Still, we are trying to factorize. But you will see that, and then there is this thing coming, right? You see something good has happened. Do you see? This thing is common. We can't just cancel it anymore, but it's common. That's a good thing at least. Is that right? Okay. So that is what I am doing. You have this, and then you have this thing. Let's write it. Now, it again, I understand it looks like a very tedious thing to do, but that is because we are still just in beginning in this. Now the task would be to factorize the thing inside the bracket, that is there inside the bracket. Okay. So we'll try to factorize this. And that is your homework. So you can do it in any way. You can expand the quadratic and try to factorize it. It's up to you. Okay. After you factorized it, then you can use the number theoretic, the factor things. So the step is to maybe try to factorize this thing further. Okay. Otherwise, also you can say that this is 2, this is 5, this is 1, this is 10. Take those cases. But if you factorize it further, it will be good. Is that okay? But what I want you guys to see your attention here is, look at this very interesting thing is happening. I can just make this plus and make this minus inside. That is. Now see, something interesting is happening. This a plus b plus c is 0. Right? These things inside the bracket, they are adding up to 0. Okay? If you go back to the first question that we had, look at this. If you write this properly, which is, this is like 3 times this thing, just putting 3. Again, you see, so if you put it this side, right, you make it minus and equal to 0. right? And then you put the minus inside, so you make this plus, which will have to make this minus. Again, you see a plus b plus c is 0. That's the theme of all these problems. But how do you use it? Maybe you don't see it now. But that is a... We will pick on this next time. Okay. So for now, if you don't see it, then you have to just try to factorize this further by hand and you'll be able to. It will take a bit more time. Okay. Right. So next time we will see the following factorization. I'm just saying it now. You can also go and just see it and just try to explore it on your own. We will be discussing this factorization, and this will have several nice properties. Not properties, properties also there. Several nice applications. Looks a bit strange, maybe, if you have not seen it, but for our picture, this was 0. And that is why this was becoming equal to sort of getting factorized in a nice way. But we'll see that. This will be the theme. So you can go and just maybe have a look at this. But first, try the problems of today, okay, at least. And so interesting stuff. So whatever we're doing is part of a bigger picture. That's happening, and that's part of something maybe bigger also, which I don't know, okay? Which I'll think of. Okay. So we will stop here for today. Okay. And yeah, and Pragadesh, so I had